Hello everybody, in this lesson I deal with more past exam questions. Example 1. Two learners, Dalvin and Calvin, exercised hard one afternoon. They both recorded their pulse rates P and time T minutes after they were done exercising. Dalvin's results are shown in the table below. So there's the time in minutes and then his pulse rate. Question 1. Calculate the equation of the least squares regression line for Dalvin's results in the form y is equal to a plus bx. So this is the time to pause the video, and then a's value will be 122,67 and b's value is minus 10,74. Therefore, the equation of the least squares regression line will be y is equal to 122,67 minus 10,74x. Question 2. Use your equation of the least squares regression line to estimate Dalvin's pulse rate after 2,5 minutes. Give your answer to the nearest whole number. So what you need is the equation of the least squares regression line, and in x's place you will substitute 2,5. And when you work that out, y is equal to 95,82, and then give your answer to the nearest whole number will be his pulse rate. Y is more or less 96. Question 3. The equation of the least squares regression line for Calvin's results is y is equal to 116,79 minus 5,61x. The fitter you are, the quicker your pulse rate returns to normal. Who is fitter, Dalvin or Calvin? Motivate your answer. So first of all, Dalvin's regression line equation is y is 122,67 minus 10,74x. We calculated that in the first slide, and then Calvin's is given. Now, when you zoom in on Dalvin's regression lines equation on that value, this is the gradient. And for Calvin, the gradient is minus 5,61. Dalvin's is minus 10,74. This means that Dalvin is fitter since the gradient of his regression line is steeper. Before we continue, have you subscribed yet? And you can also visit my website onlinemaths.co.za. Also feel free to leave a comment or like my video. Let's continue with the examples. Question 2. A familiar question among professional tennis players is whether the speed of a tennis serve in kilometers per hour depends on the height of a player in meters. The heights of 21 tennis players and the average speed of their serves were recorded during a tournament. The data is represented in the scatter plot below. The least squares regression line is also drawn. Question 1. Write down the fastest average speed in kilometers per hour achieved in this tournament. Now, the reason that I gave you this question is usually the question wants you to give the scatter plot. Now, in this case, the scatter plot was given. So for us to find the fastest average speed, we will go to this point. Can you see that? You will read off on the y-axis, and then your answer will be 251 kilometers per hour. Question 2 says, consider the following correlation coefficients. A, R is 0,93. B, R is minus 0,42. And C, R is 0,52. Question 2.2.1. Which one of the given correlation coefficients best fits the plotted data? Motivate your answer using the scatter plot and the least squares regression line. Now, first of all, the points are fairly scattered and therefore a weak correlation. The regression line has a positive gradient. So when you go back to the correlation coefficients, do you agree number B will not work since the correlation is negative? That means there is a negative gradient and our data has a positive gradient. Now let's zoom in on number A. R is 0,93. That is a very strong positive correlation. And then when you go to C, R is 0,52. That is a weak correlation. So my answer is number C. R is 0,52. Question 3. What does the data suggest about the speed of a tennis serve in kilometers per hour and the height of a player in meters? Now, the fact that there is a weak positive correlation means that the height could have an influence. Question 4. The equation of the regression line is given as y is equal to 27,07 plus bx. Explain why, in this context, the least squares regression line cannot intersect the y-axis at the point 0 and 27,07. Now, if you think about it, for the point 0, 27,07, it means that the player has a height of 0 meters, but can serve at a speed of 27,07 kilometers per hour. It is impossible for a person to have a height of 0 meters. This is the end of grade 12 statistics. My suggestion is you click on the playlist in the left-hand corner to take you to Euclidean geometry. Maybe you need to watch those as well. This is Miss Pythagoras signing off. Till next time.